Our next lesson is Chapter 5.4, using cross products to prove and solve proportions. The first part of this lesson is going to be to prove if two ratios actually do form a proportion, meaning we have to prove that they are equal to one another. What we do is we set up a proportion problem, and I use that equal sign with a question mark above it. It actually means, is it equal to? So question here is 10 over 18 equal to 15 over 27? You're going to find out with these types of problems that it really pays off to reduce each ratio to its lowest terms. Now I can't reduce across the equal sign, but I can reduce the ratio itself. For example, 10 over 18. Both of those are even numbers, so using my divisibility rules from Chapter 4, that's going to be 5 over 9. Now I look at 15 over 27, and I can, using my divisibility rules, reduce both numerator and denominator by 3, so I'm going to get 5 over 9. Now at this point, it's obvious that 5 over 9 has to equal 5 over 9. However, they want us to use cross products, which means I'm going to take the 9 times the 5 across that way, and the 5 times the 9 the other way, on the diagonal. So I will have 45 equals 45. In this case, yes, the two ratios are equal, therefore they form a proportion. Since this is a review, I would suggest that you hit pause and do both B and C, and then I will show you how to do them. Again, we're going to set them up. Did you make sure that you use that equal sign with the question mark above it, the is it equal? And again, I'm going to reduce. I can take 3 into both 9 and 12. I can also take 3 into both 12 and 15 in the other ratio. Now notice, I do not cross the equal sign and reduce the 12s and reduce the 9 and the 15. That I cannot do. I cannot cross an equal sign. Now I am going to do my cross product. I'm going to start with 3 times 5. Although, quite frankly, we usually skip that step and just go right to 15. And 4 times 4 is 16. That is not equal, so I'm going to write no. Now, the 11 over 14, the thing is, that one is already in lowest terms, and so is 23 over 28. So I'm going to have to do my cross product. 11 times 28 is going to be 308. And 14 times 23 is 322. It is not equal, so I'm going to write no. Moving on to part 2, this is where we often use proportions, is to solve them. We don't go around too much in life asking if two ratios are equal, but we do often have to solve proportions. Again, if you reduce before multiplying your cross products, it really helps make the numbers more manageable. You can often get it to the point where you can get it down to a mental math problem, where you can't always do that sometimes if you don't reduce. So I always look to reduce. My divisibility rules tell me that I can take 3 into both 6 and 15 and get 2 and 5. Now I cross product, and I always find that I should say usually, not always, but I usually put my variable on my left side, regardless of if it's on the left side in the original problem or the right side. And 15 times 2 is 30. Now if you really look at this, look, you have a one-step equation like you've had since 6th grade. Divide both sides by 5, and C will equal 6. And if you substitute it back into C, it's pretty visible. 6 over 15 has to equal 6 over 15. At this point, I suggest you hit pause and go on to both B and C. If I look at B, I'm going to take 7 into 21 and get this down to 1/3. Now I'm going to take 3 times Z equals 1 times 51, which is 51. And divide both sides by 3. And Z will equal 17. moving on to C, I really can't do any reducing. You absolutely cannot reduce a 9 and the 15 by 3 because you cannot reduce across an equal sign. You can only do that when you're multiplying fractions. So I'm going to have 4 times n equals 9 times 15, which is going to be 135. Again, I have that one-step equation. Multiply by the reciprocal of the coefficient, or in this case, divide by 4, and n is going to equal 33.75. Story problem. Again, we're going to go back to using that ratio language. And right here, you've got ratio language to help you set up what our ratios are going to be, what our proportion is going to be. This says we need to go euros over US dollars. Now, I keep that in mind when I'm going to set it up. The next thing they tell me is that the ratio is actually equal to 0.8965. Now, what that means is 0.8965 euros to 1 US dollar. Notice I'm repeating that ratio language, euros to US dollars. All right, if I have euros to US dollars on the left side, I need euros to US dollars on the right side. Now I look at my question. My question says how many dollars. That's what I don't know is 250 euros. That's what I do know. At this point, I can now do my cross product. 0.8965 n equals 250. Again, I've got that one-step equation. All goes back to equations. Divide both sides by 0.8965. Generally, they are going to ask you to round off to the nearest dollar. So in this case, I am going to get $279. And that completes Chapter 5-4, Scouting Out.